Okay, we're going to talk about homework 13. These are polynomial functions. Poly just means many and in one variable, so we're just dealing with one letter variable at a time. Like these are all x's. So it's going to look something like this. Maybe not this long, could be shorter, could be longer, but that's what it looks like. Things that are not polynomials, functions that have an x under the radical, like this. Rational functions, where you have a variable in the denominator, because both of these we have to worry about what x is. Right here, absolute value of a function, so we don't want to have to worry about that. Functions with the negative powers of x or fractional exponents, because if you had something like this, x to the negative second, you can rewrite that as 1 over x's second. Or if you have a fractional exponent like this, x to the 2/3, well, now you have a radical, okay, where you have something like this. So those are all examples that are not polynomials. All right, so we have polynomials, so they're going to tell you that are polynomials. Now we're going to talk about ending behaviors of polynomial functions. So you're sometimes going to have these graphs that look like this. All right. Ending behaviors are the far left and the far right. We're going to talk about that. Okay. So when we talk about ending behaviors, we are just talking about the far left, far right. Do they go the same direction? Do they go different directions? Is this one down on your left and up on your right? Is this up on your left, down on your right? Do they both go up? Do they both go down? We're going to talk about all that. The leading coefficient depends on the leading coefficient. Oh, wait, let's try this. Sorry, wrong thing. Leading coefficient associated with the variable with the highest exponent. Up here, this has the highest exponent. The leading coefficient is this 5. The degree is the highest exponent, so the degree of this would be 6. Okay, so how are we going to use that? Let's look down here. You can read all this, but this is what we're going to do. So let's look at this one here. The leading coefficient here is 3, and that's because this is the highest exponent. This is in order. It goes down, highest exponent to lowest. 5, 3, 2, 1, and then it doesn't have anything, okay? So the leading coefficient is 3, and the degree is 5, okay? Well, let's find that down here. The leading coefficient is, oh wait, I about messed up. I didn't look to make sure it's in order. This is not the highest exponent. This is. Now you can rewrite it, but I'm not going to rewrite it. I'm just going to leave it because the leading coefficient of this is a -1. The degree is 6. Okay. So if you were to ask me the leading, what is the ending behavior? Okay, I would just kind of draw this graph. Why? I don't know. I'm just used to drawing a sketch. Okay, so even though it says without graphing, that means without that calculator. All right. What you're going to pay attention to on the leading coefficient, this is going to tell you what the right side of the graph is going to do. This is going to tell you about the right side. This is going to tell you what the right side is going to do. Okay? Just like before with our A. This is positive. Okay? This is a positive number. So the right side is going to go up. Just like you would think. Just like on the A. All right? Right here. The leading coefficient is negative. So think to yourself what you think the right side would do. Negative people bring you down, so it's going to go down. Okay? Easy. Now, to find out what the left side's going to do, you go to your degree. Okay? If it is odd, if your degree is odd, okay, like in this case, the left side's going to go a different direction than the right. Okay. So the odd is going to tell your left to be different from your right. Okay. So if this is going up, your left is going to go down. This is even. That tells you that the left side is going to do the same as the right. Okay? If the right is down, the left is down. Okay? So, this number here, the leading coefficient, is going to say what the right side is going to do. If it's positive, it goes up. If it's negative, it goes down. In the degrees, if the degrees are even, if it's an even number, they're going to go the same direction. They're either both going to go down or they're both going to go up. If they're odd, they're going to go opposite directions. Okay? So if the right is up, the left will be down. If the right is down, the left would be up. Okay. Now, for me on a test, even though I like this, okay, when I ask for the ending behavior, you're going to go down on the left, up on the right. You're just going to do the little arrows. Okay? Here for this one, down on the left, down on the left. Okay? So, that's fine for me. In ALEKS, it is going to say falls on the left. Where does it say? Falls on the left, rises on the right. Okay, they're going to use all these words. I don't. Okay. Now here, it's not quite as easy to, you can't look at it. You got to do, you'll be able to, but you got to do something first. Okay. Right here, here's what you're going to do. You're going to take this negative 2x. This is times just an x. And if you actually multiplied this out, okay, which you don't have to, this would be x squared. Because again, I know the shortcut to this. This is really x squared minus 8x plus 14. I'm sorry, plus 16 if you do the FOIL. So that's why I just took the x. I don't really need all this because this is the only thing I'm going to take. Okay, so I'm going to take this. I'm going to take this, and this really is an x squared. Those three things, I'm going to multiply them together, and my leading coefficient is negative 2x to the fourth power. All right, so my leading coefficient is, let me erase all this, and let me put this up here. 2x to the fourth, negative. My leading coefficient is negative 2. My degree is 4. This is going to tell you that the right-hand side is going to go down. Because this is even, the left-hand side is going to go down. So, again, when I teach it, I go, okay, this is negative, so the right goes down. Because negative people bring you down, so it goes like this. Okay? This is even. An even number tells you that they're going to go the same direction. Okay? So because this is even, it goes the same. So the left goes down as well. And again, this is all you need. All right, right here. Now I'm not going to multiply all this out like I did up here. I don't have to. This one is x to the first. This one, if I multiplied x plus 1 times x plus 1 times x plus 1, my highest exponent is going to be x to the third. And it's really just this. This one, if I multiply x minus 3 times x minus 3, I'm really going to have x to the second is the highest. I know I'm going to have x squared minus 6x plus 9. I get that, but we don't need that. So in order to find my leading coefficient, this red is what I'm going to multiply. I'm going to say this is to the first. I'm going to get x, and you add your exponents. The rules for exponents is add. So 1 plus 3 is 4 plus 2 is 6. Okay. My leading coefficient is 1. My degree is 6. This tells you what the right side's going to do. Positive people bring you up. This is an even number, so it's going to go the same direction. So they both go up. Now, again, because sooner or later you're going to kind of do the sketches, okay? This tells you that the right goes up. The reason it is it's positive. Positive people bring you up. When your degree is even, they go the same direction. So that means the left is going to go up. Now I don't care what's going to happen. There's going to be some things that happen in here. Okay, it's going to go, it might go up, come back down, go up, come back down, something like that. We just don't know what that's going to look like. Not yet. We'll get there, just not yet. Okay. All right. So zeros of a polynomial. I talked about zeros in class. Zeros are where they hit, is where it touches the x-axis. Okay, we call them also x-intercepts. Okay, x-intercepts and zeros are the exact same thing. So we know how to find those zeros. We're just going to call them zeros now. X-intercepts have 0 for my y. So I'm going to plug in 0 here. You're either going to use the quadratic formula or you're going to factor. Now again, you have to know that quadratic formula. But it's x plus 2 and x plus 5. That's how that factors. So my 0 here is a negative 2. My 0 here is a negative 5. Okay. So, in ALEKS, it may want it as an ordered pair, maybe. Okay. If it does, that means negative 2 comma 0 and negative 5 comma 0. Okay. So, something else I need to tell you. Zeros of a polynomial are the values of x that cause y to be 0. So you set y equal to 0. For polynomials, factoring and using the zero product property is the easiest method. That's where you set this equal to 0 and solve. Set this equal to 0 and solve. The polynomial can have a maximum number of zeros equal to the degree. So this degree is 2. We can't have more than 2. You can have 1. You can have none. But you can't, you can have 2, 1, or 0. You can't have more. So if I was to sketch this graph so far, again, it's going to open up, right? Positive, if you were using what we just learned before, the far right is going to go up because our leading coefficient is 1. This has a degree of 2, so the left goes up. Okay? And it's going to cross, well, not here, that's for sure. That's a bad graph. But I know on this graph, it's going to cross at negative 2 and at negative 5. Right here and right here. And I know it's going to go something like this. All you had to do is find the vertex and the y-intercept, but we don't, that's not what we're finding right now. Now here, you should be happy. This, we had to factor it. This isn't factored form. Well, so is this. We don't have to do any work. Our answer here, our x right here is going to be 4. Our x right here is going to be negative 5. I don't care how many of this there are. That just means you'd have x plus 5, x plus 5. Well, we'd have negative 5 here and we'd have negative 5 here. We only need one of those. And here we have 6. All right, so this is going to, again, if it just asks for the zeros, you might be able to get away with just this in ALEKS. Okay, but we know, and I think that's all it is, but if it asks for the ordered pair, it'd be 4, 0, -5, 0, and 6, 0. Okay. All right, so now I already know what this graph looks like from things that I've ending behaviors. I've found my zeros, and this is going to help me with multiplicity. Okay, zeros have a multiplicity, which is determined by the exponent of the factor it comes from. In the example above, 4, this one right here, has a multiplicity of 1, and that is because there's an exponent of 1. 5, -5 is going to have a multiplicity of 2 because there were 2 of them. And 6 is going to have a multiplicity of 3 because you would have had x minus 6, x minus 6, x minus 6. So it is a multiplicity of 3. Now, it's going to help you in graphing once you can look at that. So right here it's in factored form. Anything with an x, you have a 0. And again, what you're going to do is you'll take each one of these. You use that 0 property to find out what it is. We just don't do this anymore because we've been doing this since Unit 1. I will do it for this one time though. All right. And if it has an x in it, you got to set it equal to 0. So I'm going to divide both sides by -5. And I have a x equals 0 right here. That has a multiplicity of 1. How do I know that? Because this is to the first power. Now, x minus 2 equals 0. Add 2 to both sides. And I get x is equal to 2. That has a multiplicity of 1 because there's really a 1 right there. And then here I'm going to subtract 4 and I get x is equal to, I don't know where I was getting an m from, I guess from multiplicity, x is equal to a -4. Well, that came from this one right here, and it has an exponent of 3, so it has a multiplicity of 3. So when you go to Phyllis and in ALEKS, zeros with the multiplicity of 1. What they're talking about here is the answer 0 and 2. They both have a multiplicity of 1. There isn't anything with a multiplicity of 2 in this case, but there is a multiplicity of 3, which is a -4. So I'm pretty sure on zeros, they'll just take these. Okay, but you need to know that they are actually points. It's where it crosses the y-axis, like this one right here. Okay, I know it's going to cross down here at -5. It's going to have 4 and then 6 right here, let's say. Okay, because I know what to do with multiplicities, and let's see if a leading coefficient. Okay, so it'd be 1/12 times my x times my x squared times x to the third. So that would be 1/12 x to the 6th. Positive, I know this right side goes like this. My degree is 6, so that's an even number. Okay, so my leading coefficient was 1/12. The degree is 6, so that tells you that the left side's going to go up as well. Now, how can I use that? Well, you haven't learned this part yet on the multiplicities, but this had a multiplicity of 1, this had a multiplicity of 2, and this had a multiplicity of 3. Okay? You're getting ready to learn this. I know that it's going to come in at -5. It's going to hit at -5 and it's going to bounce back. It's going to come someplace up here. I have no idea where. It's going to turn and it's going to come through to 4. It's going to go through it. It's going to go down somewhere down in here. And then it's going to come up through 6 and it's going to kind of snake through. It's going to be kind of wonky. I know that because I know my multiplicities and I'm sketching the graph. So let's talk about, and that's what we're getting ready to get into. X-intercepts. The maximum number of x-intercepts for the polynomial is a degree. Remember, like the degree right here, it cannot have any more than 2. It can have less, but it can't have more than 2. This one can't have more than 6. Notice it only had 3, and it could have 6, but it didn't. Multiplicity's effect on the graph. The behavior near the x-axis around zeros is affected by the multiplicity of 0. Even multiplicities do not cross the x-axis, but instead touch it and bounce off. I say they touch it and bounce back. Odd multiplicities cross through. The higher number, the flatter the graph becomes near the 0. A multiplicity of 3 is odd, so it crosses. So basically what they are telling you here, because I don't think they give us... No. Okay. So what we're talking about is if it's a multiplicity of 2, let's say, let's say we have, anyway, it doesn't matter. If it's an even multiplicity, it's going to hit it and bounce back. Rather like that. It could be coming like this, hits it and bounces back when it has a multiplicity of 2. If it was 4, it would just come in flatter and kind of look like it lays on that line a little bit more, but we're not going to deal with that. We're only going to deal with 1, 2, and 3. If it has a multiplicity of 2, let's talk about 2 and 3. Multiplicity of 1, I'm in multiplicity of 1 and 3. Okay, like again, if it was 4, well, I'll come back to that. If it's going to cross through right here, or if that is a 0, if it's coming in like this, it's going to cross through, kind of like that. Okay, crosses that x-axis. It could also come like, if it's coming from down here, it could also come and it crosses. Okay, that's with the multiplicity of 1. So multiplicity of 3, what it's going to do is it's going to kind of snake through. All right, it's still going to cross, but it snakes instead of kind of straight through. If it was a multiplicity of 4, it still would come in kind of flatter and come back down like that instead of more of a point. Okay, and turning points. A turn is located at it's the maximums and minimums. The maximum number of turning points for the function is 1 less than the degree. Okay, so now we're going to talk about it. And to me, it's easier to do this than to go up and do this, but we're going to start right here. All right, so let's talk about intervals of increasing. Now notice increasing and decreasing, all parentheses, all x values. So we're increasing. So it's increasing here to here. That means between here and here, it is increasing. Your x values only. We talked about this on the last unit. So from -9 to -7. Okay. It also increases here. What x values does that fall between? And again, You could use, oops, let me grab a post-it note here. A couple of them. Okay. Here's where it increases. Between what two numbers does that increase? From here over to here on the x-axis. Okay. So that is from -3 to a +1. Okay. And then it also increases here between this number and that number on the x-axis, because that's all we're dealing with is the x values. Okay. All right. So that is between 4 and 6. Okay. All right. Local maxima at which x values? Okay, that means maximum. Here and here. Oh, and here. Okay. I'm going to erase all this other stuff because we don't need it now. All right. And it says at which x values. Okay, so basically this right here is at -7.5. That's the maximum. But it's only asking where it happens at the x value, so it's at -7. This one right here, that is at the point 1, looks like 2.5. It's not asking for what that maximum is, it's just saying where is it happening, and that is at 1. And then this one right here is the point 6, 2. And again, local maxima at which x value, it's at 6. All right. Sign of the leading coefficient. You only have to look at the right side. The right side goes down. This right-hand side goes down. So is it positive or negative? It is negative. Okay. Now, this one right here, possibility for the degrees. This one's kind of hard. Okay. All right, so you count your turning points. You count your maxes and mins. There's 1, 2, 3, 4, 5, 6 turning points. Okay? So it can't, it's gotta be, what was it, 1, it's the maximum number of turning points of a function is 1 less than the degree. So if it has, again, 1, 2, 3, 4, 5, 6 turning points, so 1 less would be 5. Okay? That's the maximum it could have. And it's going to be an odd degree or it's going to be even. So you would pick all the odd numbers that are lower than 6, or you'd pick all the even ones. Oh, I didn't even talk about that. Oh, I just happened to guess right. Because my choices are here. Those are the ones that are less than 6. But I know that these go different directions. All right. The left is up and they go different. That means that it has an odd degree. All right. It has an odd degree. So that means it's 5. If there had been a 3, I could have circled that one. This is going to be the hardest part. Right here, intervals are decreasing. It decreases. Oops, nope, it does not. You read it left to right. It decreases here, and it decreases over here. Okay? Again, x values only. It is decreasing between those 2 points. That is from -6 to -3. Then it decreases from 1 for the rest of the time. So it's 1 to infinity. Because again, x values only. We're not worried about the y's. Okay. Minimum. We got one right here. And that's it. And it asks for the x value. Well, that is the point. It's going to just be -3 because that is the point, -3, 2. But it only asks for the x values where it occurs, which is -3. If it asked for the minima, you would put 2. Sign of the leading coefficient. The right side goes down. So that means it is negative. If they were going up, they'd both be positive. Possibility for the degree. Okay, so right here, we have 1, 2, 3 turns. Okay, we have 3 turns. Oh, crap, I think I told you wrong over here. I did. I do this every single time. All right. This is wrong. Sorry. This is wrong. It has 6 turns, okay? So the maximum number of turns a function is 1 less than the degree, okay? So that's the maximum. So I know it's an odd number, so it's 6. It's going to be 7 and 9. It doesn't mean it's got 6 turns. 1 less than 7 is 6. I know it can't be 8 because these go different directions. 9, 1 less than that is 8. It doesn't have to be 8. It just can't be more than 8. Okay, so this answer was 7 and 9. I knew I was going to do that wrong. Sorry. This one has 3 turns. Okay, so 1 more than that. This is going the same direction, so I know it's even. So it's going to be 4, it's going to be 6, and 8, all of them. Because if the degree is something like -2x to the 4th power, let's say, 1 less than the degree would be 3. This has 3 turns, okay? If it had been this here to the 6th power, 1 less would be 5. It doesn't mean that it has to have 5. It's just possibly 5. And then 8, same thing. All right, sorry about that one. All right. It gets me every semester. All right, now we're going to sketch a graph. Okay, we're going to use all that we've learned about graphing. Okay, so first off, let's find our leading coefficient. This is -1. So we got -1 times x here times x to the 2nd power times our x. Okay. Now, that's going to give us -1 x to the 4th. So our leading coefficient is -1. That tells us that our right side goes down. So I'm just going to do that. It's just hanging out there for now. Okay. Then my degree is 4. That's even. So my left is the same. It goes the same direction. So it's going to go down. So again, I just do something that looks like this on my graph. Probably not even going to use those. I will use it to a certain extent, but I'm not going to connect it probably. All right, the next thing I'm going to find out is my zeros, okay? And its multiplicity. So, in this case right here, this has an x, okay? So this has, my x is going to equal -3. And it has a multiplicity of 1. because there's a 1 right there. This is going to be negative 1. So I have x equals negative 1. It has a multiplicity of 2 because of that exponent right there. And then this one is a positive 1. And it has a multiplicity of 1. Okay. So here's how we're going to use this. We're going to put a 0, we're going to put a point at -3, -1, and 1. All right, so let's see. These are we'll just do it. Here's what I'm going to do. I'm going to count every other one. Okay. Here's 0. I'm going to make that -1. I'm going to give this -2, and then every other one -3. Okay. You don't have to. It's just going to spread our graph out. Okay. So here's 1, here's -1, -2, and -3. Over here, this is going to be 1, 2, and 3. Okay. Not that you need all of those. Okay. It just is making our graph better. I wish we didn't even have numbers. These tens or the graphs, it makes it nicer. Okay, so I'm going to put points. I have a 0 at -3. I have a 0 at -1. And I have a 0 at 1. The only other thing that I would probably do is find that y-intercept. But it probably doesn't matter for this one. And that's where you just plug in 0. So let's find our y-intercept. If I plugged in 0 over there in those, okay. I don't know. Let's see if it'll fit on this graph. That would be 0 plus, okay, we have negative. Let's do 0 store x, and we're going to have to, it doesn't matter. You don't really have to do this. I can do it without it, but let's just do it. X plus 1, and that's squared, times x minus 1. Okay, I was going to say it was kind of small. I knew it. So again, let's do 1, 2, and 3. Okay, so our y-intercept is 0, 3. Just gives us something else. All right. Now, how do I use this? Remember, odd multiplicity cross. So it's going to cross the x-axis. This is going to bounce back. I probably should have put this 0, 3 someplace else. Okay. This is going to bounce back in the same direction. This is going to cross, but because it's a 3, it's going to kind of, I say, snake through. Another instructor says it's kind of wonky. So, okay, so this is kind of crooked now. All right, so 0, 3. All right, so let's use this. Now, at -3, right here, it crosses the x-axis, okay? So it's going to start like this, and it's going to cross. It's going to come up here, and it's going to turn and come back to a -1. At -1, it has a multiplicity of 2, so what's going to happen is it's going to kind of come up here someplace, I don't know where. It's going to turn, come back to -1, and because it had a multiplicity of 2, it's going to bounce off of that x-intercept and go back up. And that's what an even multiplicity does. Then it's going to come up here, hit 3, turn, come back down to 1. Ooh. Hold on just a second. I don't know where it turns up here. This is where it kind of gets hard. I'm going to say comes here, comes back down to 1, but it had a multiplicity of 3, so it's going to kind of snake through. It's going to kind of come through wonky. And it comes down like that. Notice my ending behaviors. Let me erase this so it's a little bit neater. Okay, so see how this crosses and this snakes through. And again, this isn't the best. It probably could have just gone like this actually, but it doesn't matter. All right, let's do this one. We have that x squared. This here will be an x squared because of that. This is just going to be times x. That's going to give us x to the fifth. The leading coefficient is 1. The degree is 5. Okay? Because this is 1, the right goes up. Because this is odd, the left goes down because it's different. Okay? It's different. So it's going to go like this. Okay? Easy enough. Now, let's find our zeros. This, we have an x. If you set that equal to 0, you're going to find x is equal to 0 with a multiplicity of 2. That's going to tell you that it's going to bounce. This, x is equal to -1. It has a multiplicity of 2, so it's going to bounce. This has a x is equal to 1, and it has a multiplicity of 1. So it's going to cross that x-axis. Okay? All right. If we plugged in 0, and our y-intercept is at 0, 0. If you plug in 0, this gives us 0. 0 times whatever, this is 1 times 1. -1 is still going to give you 0. Okay. So, let's draw this. We got 0, -1, and 1. Ooh, that's going to be really tight. So, I'm just going to do this. I'm going to count out to 4. 4 of those lines. And I'm going to make that -1 here. Here's 0. And I'm going to count out 4 here and make it. It just helps in the graph. It's just kind of tight on these little squares. That's what they are. So it's really hard to deal with them when they're that close. Okay. So you start from the left. Now again, I could have put it all in here, but it's going to be really hard. We're going to start with a -1 because we get to that first. Here's where your 0 is right there. Okay. Because of this ending behavior, it's going to come up to a -1. It has a multiplicity of 2, so it's going to bounce. Okay. What that means is it's going to come down here. It's going to start here, come up to that point, and bounce back. And it's going to come and turn somewhere. I don't care where. Okay. It's going to turn and come back up to 0. But 0 has a multiplicity of 2, so it's going to bounce back. Come someplace down here, I have no idea where. It's going to come back up to 1, and it's going to cross through. And notice my ending behaviors match. I just don't know what these minimums are and that maximum. It's okay. It's just a sketch, and that's it. And that is 13.